Hello, welcome to the CZ4041 project presentation. We are from Crew 13. This is the agenda for this presentation. Firstly, we will discuss about roles and responsibility of each member for this project. Secondly, we will discuss about the Kaggle projects that we choose and the problem statement. After that, we will briefly discuss about the Kaggle score and ranking that we got. We will be discussing about the data analysis and proposed solution that we have for this computation. We will be talking about data preprocessing, feature engineering, and two machine learning models that we use for our project, which are LightGBM and neural network. We will be discussing about the cross validation and ensemble forecasting method that we use for our project. Lastly, we will end this presentation by highlighting some of the challenges that we face during the project. So this is the roles and responsibility of each member. Hi, I am Akar, and I'm in charge of data preprocessing, time series forecasting using LightGBM and neural network. And also I'm in charge of doing the ensemble forecasting using the weighted average and report and presentation preparation. Kai Hao is in charge of doing initial data analysis, report and presentation preparation. And the rest member, Binu, Dong, and Wan Qing are in charge of research and machine learning techniques and report and presentation preparation. So let's talk about the problem statement. We choose correlation Farida grocery sale forecasting computation. It is a kind of time series forecasting computation. What we are required to do is we are challenged to predict the sales of items sold in different branches of collaboration Farida for next 16 days. 8 different data sets are given. They will be using the normalized weighted root mean as an evaluation metric. So let's talk about the Kaggle score and ranking. We did well in private leaderboard compared to the public. We got the score of 0.52013 in private, getting the ranking 99 out of 1,675. And our score for public leaderboard is higher than the private. We got 0.51276. However, we only get the rank of 358 out of 1,675. As you can see here, there is a huge difference between the public and the private leaderboard. This is also one of the talking point about this computation. People are getting the huge different ranking compared to the public and the private. So now let's talk about data analysis that we did. We believe that before diving into any machine learning algorithm, it is important to understand the data we have. So we did the data analysis first. We first checked the present or null value inside the data that we have. This is because having a null value can be harmful to the time series forecasting. And after that, we try to find the relationship between the given feature. For example, we are given the OI data and holiday data for this computation. So we try to find out whether there is a relationship between those data and the sales data. And thirdly, time series forecasting always involve trend and seasonality. So we try to figure out whether they exist in our data or not. Then we explore the nature of transaction and store location holiday data. This is another data analysis we have done. We plot the graph for Y data and unit cell data to look for the relationship between them. And apparently they don't have any distinct relationship here. The second graph shows how unit sales are distributed across the year. We can clearly see the uptrend. There are some kind of seasonality in 2014 and 2015. However, the rest periods are quite random and there are a lot of spike in the data. So let's talk about our proposed solution. We propose a ensemble forecasting model, which consists of LightGBM model, LGBM, and neural network, NN. We will be using unit sales and promotion as our info feature, and we will also include the perishable item as a weight into doing training our model, because these perishable items are also used as a weight in evaluation metric. So we think it is better to use those as a weight in our model also. Now let's talk about the data preprocessing. We are given a very large data set, which include all the sales data starting from 2013 to 2017. The data set is around 4.65 gigabyte. It is quite large, and it took a lot of time just to open the file. And also for our training the model, we decided to use only 2017 because of the inconsistency in data we have seen earlier. And since we will be forecasting the sales of 2017, we assumed that it is better to use only the 2017 data. So as a result, the training CSV is split into 4 smaller training data set and 1 validating set. So train set short and train set long and validate set are used for initial stages when we exploring different ML algorithm. At that time, we didn't aim to get a very high accuracy. We just want to figure out which ML algorithm are better, so we only use a small data set. And later the time, we use a train set and train set 1 year as our training set and validating set. We are not using the valid set for later state anymore because that data is only for 1 week. For our project, we have to predict the sales on next 16 days, so it is better to have a validation set which has also 16 days. So for later state, we use the data from train set and train set 1 year, or we use the data from train set and train set 1 year for validation set also. Now let's talk about feature engineering. This is one of the important part of our project since our project has very limited feature. So we produce the mean, medians, and standard deviation of all unit sales, which are 3, 7, 14, 30, 60, and 140 deals before the next 16 deal sales prediction. We also produce the mean, medians, and maximum numbers of promotion before next 16 deal sales prediction. We also produce the mean weekly sale, which start 4 weeks before and 20 weeks before the next 16 sale prediction. By producing this new feature, we hope to capture any pattern that exists before making prediction. Now let's talk about our model. In every Kaggle, computation gradient boosting frameworks are very popular. Also in our project, we will be also using one of the gradient boosting framework. The framework we are using is a LightGBM, which is a gradient boosting framework that uses the tree-based learning algorithm. It has a faster training speed, higher efficiency, and better accuracy. And it has support for both parallel and GPU learning. However, it is sensitive to overfitting and can easily overfit the small data. But since our data is very large, LightGBM shouldn't give any problem. Another thing about LightGBM is that it grows the tree vertically while other algorithm grow the tree horizontally. So this means that LightGBM use the leaf-wide algorithm when other algorithms use the level-wide algorithm. Because it's used the leaf-wide tree algorithm, it can reduce more loss compared to the level-wise algorithm. Now let's talk about neural network. The neural network that we use is a 7 hidden dense layer neural network, and each layer contains 512, 256, 128, 64, 32, 16, and 1 neuron respectively. We will be using ADEM as an optimizer. Activation function for each neuron is a ReLU activation function. This neural network we have is slower during training process when compared to the light GBN model. So let's talk about the cross-validation. Both LGBN and neural network model are trained in such a way that they will be trained until their cross-validation does not improve anymore. So we have to do the cross-validation for both training set and validation set. We also make sure that the validation set include the sales or next 16 data, which is the same as the test data, in order to get a better result. We will be using the mean square error as a validation metric. And lastly, the ensemble forecasting. We will be using the weighted average ensemble forecasting method. During the training, we find out that light GBN always produce better forecasting than neural network. So as a final model, we decided to give 60% weightage to light GBN and 40% to the neural network prediction. With that, we get our final model. So to conclude, these are some of the challenges that we face. The first problem we face is we does not have enough data. What we are saying is that although we have a lot of large training data set, in order to predict the sale for each store location, it is better if we have the demographic of the population in which each store is located, so that we can make a very better intuitive prediction. And also, even though we are given holiday data, wine data, it is hard to relate those data with the unit set that we have. And the problem is, I mentioned in the feature engineering, we do not have enough input feature, so we have to produce the feature by our own. Lastly, both LGBN and neural network model has a lot of parameters that we can control, so it is hard to find. It is very time consuming to find the optimized parameter. So we spent quite a lot of time fine tuning both LGBN and neural network. So this is the end of our presentation. We learned a lot from this project, and I hope you enjoy my presentation also. Thank you.